Kia ora, Year 12 and Year 11. This question's coming from Chinmay and it's from Chapter 8F of the textbook. It's question 7 in there and it's an integration by parts question. So we're given a function that looks like this. The only difference in the textbook is that you don't have those values on the x-axis, right? And the question goes like this. The sketch shows us the curve of this function here. Y is equal to x squared natural log of 2x, and you can't see those values. So you have to find the area of the shaded region by first finding the value where the function crosses the x-axis. And so in the book, what's shaded in is a pretty clear vertical line down here at 1, and then it's shaded like this, right? But you can see here that that second limit of integration is going to be 0.5. Whereas in the exam paper, you had to figure that out. And Chinmay's question was with that first part of the question, which is just to go over how we find that value there. So what's happening here is that the value of the function is equal to 0. Also have a look and note that the function y is defined only for x is strictly positive, right? Because we're taking a natural log and the log of x function has to have x greater than 0. So what do we want to do to find where y is equal to 0? Well, we're going to set this x squared log of x is equal to 0. So we either have x squared equals 0, oops, it's the natural log of 2x, or the natural log of 2x must equal 0. But x squared can't be 0 because we've got x has to be positive for this function to exist. That leaves us with the natural log of 2x equals 0, which means that 2x must equal 1, giving us x is equal to 1/2. Okay, so now we're good to go. How are we going to find the area of that shaded region? Well, I'm just going to integrate the function between these two limits. So let's do that now to run over how integration by parts works. So we're trying to find this limit. And before we launch into integration by parts, just have a look and check if you've got the pattern where you've got an easier backwards chain rule thing. And you can see pretty quickly that you don't. Okay, so this is going to be IBP. I'm going to look at this and think about which bit am I going to leave and which bit am I going to differentiate. Well, we know that it's really hard to integrate the natural log of x. So that's not going to be the bit we integrate. We know that it's easy to integrate x squared, but it's going to make it messier. So usually in IBP questions, I'd say that's probably not going to be the one we choose to integrate, but here it is, because this one here, we can't integrate, or we can't integrate without going and doing a bunch of integration by parts work, right? So this is going to be the bit we integrate, this is what we leave, and then in the second part, we're going to integrate this again, and we're going to differentiate this. So in the first part, we integrate the x squared and we get 1/3 x cubed, and we just leave the natural log of 2x. I don't know why I keep forgetting that 2x, but I do. Okay, so it's times the natural log of 2x. Just clean that up. Integrated between 1 and 1/2 minus the integral from 1 to 1/2 of 1/3 x cubed, and this time we differentiate this. So we're going to get 1/2x times 2. So that's just a little chain rule thing going on there. Now you can do this in lots of different ways. So I know some of you will probably want to go ahead and figure that out and then come back to this. I'm going to do it all in one big calculation at the end. So we'll just let this sit here. 1/3 x cubed log of 2x. And now here, this is going to simplify to give me minus the integral of 1/3 times x squared dx. So finally, this is the integral that we're going to get. So it's going to be minus 1/3 times 1/3 x cubed between 1 and 0. And you can go ahead and evaluate that now, which is probably what most of you would do. Or if you want to, so this is optional, you could clean it up a step more before you go ahead and substitute in your limits. Okay, so either way is fine. Right, so I'm going to just do it, because I've gone ahead and done this step here, I will do it using the simplified version. So we're just about at the end of the first question. So we're going to have 1/3 times 1 times the natural log of 2 minus 1/3 minus, oh, that's not 0, sorry, that limit's 1/2. Right, clearly haven't had enough coffee yet. Right, so this is going to be minus 1/3 times 1/2 cubed times 1/8. The natural log of 2 times 1/2 is 1 minus 1/3. Right, that gives me 1/3 log 2 minus 1/9 plus, now this is 0, so it's minus 0 plus 1/72. That gives us 1/3 log 2 minus 8/72 plus 1/72. I haven't been asked for this as an exact value, but that's how I usually start with A-level questions, right? So that's my exact value answer. If we want to get that to 3 significant figures, chuck it in your calculator and you should get 0.134 and it's units squared. And if we go back to, go look on the next page, you can see there that that's the correct answer. So that's the integral evaluated in GeoGebra, and that's that one. But I wanted, because this video's, you're watching it, you might as well keep watching, I wanted to chuck in this one extra question, which is to ask you to find the coordinates of the stationary points for this. I don't need you to check what they are, whether they're maxima or minima, but let's just practice how do we find the stationary points for a log function while our brains are working with log functions. So we need to solve dy by dx equals 0. This is practice at the quotient rule, so it's going to be x squared here, then x times the derivative of the top line. So it's going to be 2 times the natural log of x times 1/x minus the derivative of this, so minus 1 times the natural log of x squared. Right, remember that my quotient rule is this, so it's square the bottom line, copy it up, differentiate the top, minus the other way around. And it's fine if you want to go and do this UV process more slowly. So here, what have we got? Well, let's clean this up. We've got 2 log x minus the natural log of x squared over x squared equals 0 for a stationary point. So 2 log x minus log of x squared over x squared equals 0. I'm going to multiply both sides through by x squared, leaving me with just the numerator. And we've got a common factor of the natural log of x times 2 minus the natural log of x equals 0. So either the log of x equals 0 and x equals 1, or 2 equals the natural log of x is equal to e squared. So that's my first part, but I haven't found my y values yet. So I need to take those and sub them back into the function. So y is equal to the natural log of x squared divided by x. So when x equals 1, y is equal to 0 squared on 1, which is 0. So the first stationary point, oops, something weird's happened, just a sec. So the first stationary point has coordinates 1, 0. And then this one here, y is equal to the natural log of e squared divided by e squared. Right, so what's all of that? Well, the natural log of e squared is just 2, so it's 2 squared over e squared, which is 4e to the negative 2, if you want to write it like that. So the second point has got coordinates of e squared and then 4 over e squared. So there's your first and your second stationary points. All right. Thanks very much, Chinmay, for sending that in. If anyone else has got questions that they'd like done, just chuck me an email and I will get on with them. Also planning on doing some old stats exam questions for you to work on over the next few days. Thanks for watching.